Hi, I'm Devti Keskar, and this is my machine learning dashboard project on health and lifestyle clustering. So, using unsupervised learning, I grouped individuals based on their lifestyle habits like sleep, diet, stress, smoking, alcohol consumption, etc. So, let's take a look at this dashboard that I created. First of all, there is this data preview. So we can say all the features in this data set, that is age, gender, height, weight, BMI index, if the person is a smoker or not, exercise frequency, diet quality, alcohol consumption, chronic disease, stress level, and sleep hours. Based on this, we did the clustering of individuals into four different groups. So here are the clusters and cluster summaries. From here I can select any cluster and I can get the data that is uh, that describes that particular cluster. So this is a radar chart that I created using the cluster data, and this is a bar plot to, for example, if I want to check the diet quality of every cluster. So how is it? So I can see it here. The clusters are mapped on the x-axis and the diet quality on the y-axis. Similarly, if I want to check the BMI index, I can do so. So this is the dashboard that I created using Streamline. Now let's take a look at the notebook. So here we have read the data. As you can see, this is the data, which is the synthetic health lifestyle dataset on Kaggle, available on Kaggle. Uh, 7,500 rows and 13 columns are present in this dataset. So here we did some exploratory data analysis, which is the first step of any machine learning process. So here uh, we can see the count, the mean of every feature that is present there. The one and two notable things about this is the age. The mean age is 43. The minimum age is 18, and the maximum age is 69 over here. Okay, so this information will be useful to us. Then this is the information of data types and everything about the features. Then we can see that there are some values which are null present over here. So we can see exercise frequency and alcohol consumption has some null values. So we will first check for percentage of missing values per column to see which method to use to fill the null values. So this is how I check the percentage. So 25% around that was the percentage of missing values. So to handle these missing values, first converted the values of exercise frequency into numerical format, which was in this format firstly, 1 to 2 times per week. So I converted 1 to 2 times into 1.5 and 3 to 5 into 3.5. Okay, and I kept the null values as 0. Then after that, I filled the null values using the median of that data. After this, we can see again that we also have to convert the alcohol consumption column uh, into its mode value, as it's a categorical variable. So we did that. Now the null values are all 0. It means there are no null values in the data. So here we also dropped any kind of duplicates if there were, which were not present in that data set, which it's a really good data set. So here, first of all, uh, we check the value counts of each feature, which I think could be useful, such as gender, if smoker or not, diet quality, which are basically the categorical variables. So to check if they are imbalanced, so we can see that gender is quite balanced in this data set. Smoker is not very balanced. That quality is quite balanced. Alcohol consumption is not that balanced, and chronic disease is again not that balanced. Then we tried to find the outliers and remove them. So for that, we used uh, all these features, which were the numerical columns first of all. Uh, then we created the IQR using the IQR method. We detected the outliers, and we changed the data frame into the data frame that does not contain any outliers. So these are the formulas to find the IQR range. First we find the Q1, Q3, then the IQR range, and then the lower and upper bounds using these two formulas. Then we mapped a box plot for each of those variables to identify any kind of outliers if they are present. Then here we used standard scaler to fit transform the numerical columns data, and using that scale data we trained it on k-means clustering algorithm. So the number of clusters were initially 4, and here we can see we have used the scale data. Then we use the radar chart for visualization. So the reason that we use the radar chart was firstly because radar chart is excellent for clustering tasks. It gives us it maps features along with the clusters against the clusters. So here for example I can see that cluster 0, it has its average age is near to 1, which means 0 to 1, it means it is the maximum. Then we can see height is also maximum, its average height uh, according or we can say compared to other clusters. Okay, so we can, if we particularly observe this orange cluster, we can see it has its age coordinate is nearly at 0. It means the youngest person could be belonging to this cluster. As we saw earlier that the youngest person was 18 years of age, so he or she could be belonging to this particular cluster. Now what's the significance of this is that we can see that okay, maybe 18-year-old, the average age is very low. So in the age, people of the age group 18, 19, 20 belong to this orange cluster. So we can see that yeah, right, their weight is quite at the median. Then we can see that BMI is also balanced. The stress levels are also here. It shows that at medium, and the sleep hours of course at the highest. Then we can see, so here I had not added the these all features that I took were natural features, or we can say these features that are physical features but not the lifestyle features such as smoking or alcohol consumption. So here I transformed and scaled those features as well. Here you can see, and then I added them again. I trained the dataset again, trained on that dataset again, and here I again mapped a radar of those clusters as well, which can be seen over here, right? So as we can see that because I just wanted to check because of these features how much the cluster range changes. So we can see that here the cluster orange cluster was the cluster 2, cluster 1, okay, right, cluster 1. So if a person is 18 years of age, he or she might also be at young age they could be smokers, or they could have high quantities of alcohol consumption. So these are the kind of insights that I understood or got from these radar charts. So this was the output of this project, and here as you can see I can check all these things for each and every particular cluster. So that is the crux of this project,